Um, so I had a blast listening to them, and of course, the brightest and nicest speeches that came out on stage yesterday. Redefining the world of information technology as it is. Today, we have an interesting, eclectic mix of keynotes, panel discussions, and workshops before ending the day with India's greatest sports person ever. At NTLF, we've always tried to create partnerships at the global level. So it is my pleasure to announce that today is the Japan Day. Yesterday was Canada Day, and today is Japan Day. Please welcome Piyush Sinha, Deputy MD, NEC, to come on stage and welcome everybody in context of the Japan Day.
Thank you. Minasan, ohayo gozaimasu. Everyone, good morning to people who don't understand Japan and Japanese. But it's my pleasure to welcome all of you to this NASScom Technology and Leadership Forum. And today, as my beautiful host for the day, announced that today is a Japan Day. We have a special focus on a country which is the third largest economy in the world. The political, economic, social, technology factors, if you look at it, India, Japan, the political tie-ups, the strategic tie-up is probably at its best. But still there is a big paradox that Japan as a country has a lower single-digit share in the Indian IT industry. And I think all of us in this room who represent the Indian IT industry, as we call it, have tried various means, various processes of forming strategic partnerships, forming joint ventures, acquisitions of companies, having nearshore centers in Japan as well to cater to this market. But I think all of us have met with limited or no success. So it's a mystery, and Japan as a geography, but it poses immense potential. And that's why, as an industry, we want to focus on this day on what it takes probably to break this paradox and have more Japanese companies and enterprises leveraging India as an IT industry like the rest of the world do. So, but if you look at deeper down, the Japan outsourcing and offshoring model is probably at a different stage of the curve, whereas we as Indian IT industry, we deal with the western side of the world, which is on a different stage of maturity in terms of the outsourcing model. So there is a need to look at Japan with a different lens than what we are used to. So that would be, in my opinion, one of the most important factors. I've been associated with Japan for the last 15 years, and last 10 years we have been badgering this thing about India and India, leveraging India and India IT industry. And it is now that my management in Japan, which is a 120-year-old company, IT and communications company, is waking up to the fact of the power of India. So there is a way, and all of us are gathered here today, and I would recommend that we utilize this day to kind of share our ideas, mix our thoughts together, come out with that winning formula, and look at this attractive market on how probably we can open the doors. One of the other challenges that I see, that when we kind of position India, when we position our companies to Japanese customers, it's mostly about offshoring, about cost arbitrage, about skill advantage, about what India has to offer as an offshoring destination. But traditionally, Japanese companies, they are interested in offshoring and lowering down their cost, but probably their expectation from India, and based on my experience purely, is also to leverage India, not only as an offshoring destination, but they have a huge eye on the big domestic market that India possesses. So as an offering, when we are going to them, it's not only about offshoring, it's about India as a market. And basis the recent interactions over the last 5-6 years, one of the other expectations that has cropped up in a big way, that they want to leverage India as a window to the world. Because from Japan perspective, where they look at it, and the map is different. They are at the center, and India is not at the center. So ultimately, the world map view of Japan is different. But how do we create this window view for Japanese companies to not only leverage India as an offshoring destination, but as a domestic market, how do we help them expand their presence in this market? And how do we help them leverage India and our relationships and with customers in the US, Europe, and all, to take them to those markets as well, handhold them in those markets. So please utilize this day today to share ideas, to collaborate views and visions on how do we penetrate this market and how do we give a compelling proposition like we give to the rest of the world. So thank you, and once again, a warm welcome to all of you. Thank you.
Thank you so much, Piyush. Truly, collaboration and partnerships always trigger expansion if done right. With that, let's move on to the first session of the day, 3 back-to-back sessions exploring tech shifts defining the 20s. To introduce this session and set the context, I would like to invite Sudhir Singh, CEO and Executive Director, NIIT Technologies, to introduce the speakers as well for this session. A brief about him. He brings experience across Hindustan Lever, Infosys, and Genpact to bear on his current role. He has 24 years of industry experience with an exceptional track record of execution, driving robust revenue growth and margin growth simultaneously, executing business turnarounds, and orchestrating successful acquisitions. He's a graduate of the Indian Institute of Technology and IIM. He's based in Princeton, New Jersey. He's also a field hockey player. And he is the expert you want to meet if your kid is writing the SATs and wants to score really high. He also started as a sales manager in HLL, selling soaps, detergents, and salt in this very city, so he knows this city like the back of his hand. Ladies and gentlemen, put your hands together for Sudhir. Sudhir, the stage is yours.
All right, and a very good morning, ladies and gentlemen. Come on, you guys responded to Shreya, right? A very, very good morning, ladies and gentlemen. Good morning. Yeah, that's more like it. That's more like it. We've got a very interesting session today. Shreya talked about it. The tech trends that are likely to impact the next 10 odd years, the next decade. Now, that's an interesting topic, but what makes it fascinating is the 3 speakers who we have today. The folks who are going to be talking about it. These are 3 folks who actually pulled up their sleeves, they've rolled up their sleeves, they've put on the elbow grease, they've started businesses using these technologies. They've succeeded in the businesses that they started using these technologies. And they're out here to talk to all of us about what these technologies mean, how you actually end up applying them, and what the potential ramifications of applying them successfully might be. Now, given the fact that we have these 3 outstanding folks who are going to be talking about quantum computing, they're going to talk a little bit about the MarTech ecosystem. They're going to talk a little bit about hyper-converged infrastructure. My role over the next 3 to 4 odd minutes to begin with is going to be largely restricted and driven by what I had seen scribbled on the back of a temple wall in the very, very ancient city of Varanasi in Hindi once. Some very wise soul had scribbled, and I quote, "Kripya gyan mat dijiye, yahan sabhi gyani hai." So, please do not, let me just make sure I translate that. Please do not offer way too much wisdom. We're all pretty wise out here. That's what that scribble at the back of the temple said. What I am going to suggest to you folks over the next 85 odd minutes is when you actually hear Dheeraj talk about how to use the open ecosystem and draw parallels with what he's done in the whole hyper-converged infrastructure space, when you hear Brian talk about the digital future and what quantum can do, try to slot these technologies in 1 or 2 buckets. There's the open ecosystem conversation. It's here, it's now, it's made a very clear impact, but the conversation today is also going to be framed in the context of what does the overlay of blockchain, cognitive AI in the future on the open ecosystem environment mean for us, and what are the changes? What is the impact that that is likely to drive? That's one. The second bucket you might like to focus on, and that's something that Brian's going to talk about, is quantum computing. Now, quantum comes with a question mark or maybe a couple of question marks around whether it is actually going to be real and drive impact in the next 10 odd years. But if it were to become mainstream, our submission to you as a collective group of 4 is that the changes that could happen across industries would be very, very significant. So that's one lens. The other way of doing it, framing it, trying to make this conversation real, because finally at the end of the day, this is a bunch of hypotheticals we're looking at, right? Is play along with me for the next minute or so. Step back into the same room, same set of people. But just imagine for a second that this is NTLF 2010. It's not NTLF 2020. It's February 9th, 2010. It isn't February 9th, 2020. And let's assume that we were discussing the same thing that we're discussing right now. My question to you folks is, which are the emerging technologies that you would have thought of in 2010 February that would have likely impacted the next 10 odd years? Throw them out. I hear a very tentative mobile. Virtualization. Did someone say cloud? I feel like an auctioneer, but someone said cloud. 2010 February, what were we talking about? You're absolutely right. There was mobile that we were talking about. The iPhone had actually got launched in 2007. There was cloud. There was virtualization. There was a lot of conversation around green IT. I don't know if you guys recall this, but at that point in time, 2010, green IT is what everyone was talking about. What else were we talking about? Social media. Anyone else? Automation. Outstanding. You covered most of them. Flash memory, green IT we talked about. Wearables, data, advanced analytics is something else that we were talking about. Now, think through everything that we're cycling out here. My submission to you is that the two that made the maximum impact across industries, not tech alone, were, and I throw this out at you, maybe cloud, and maybe mobility overlaid on cloud. The success of cloud technologies when applied to industries, and those of us from enterprise IT will relate to it, is what has actually led to the successful establishment of the titans of 2020, the year we're sitting in. Salesforce is a prime example. The success of the application of cloud technologies over the last 10 years really meant that some of the tech titans of 2010s that were flailing a bit, Microsoft is a great example, were able to engineer a remarkable, a very smart, a very sharp turnaround. The success of cloud technologies that somebody out there talked about is what actually meant that an industry which in 2010 we might not have regarded as a technology industry got disrupted by Tesla that came in with a car as a service model. That was cloud. Mobility overlaid on cloud is what we heard about all through yesterday, right? The whole everything as a service economy. The examples that we heard right through yesterday around everything as a service was the other impact that we felt, not just as technologists, but as business leaders straddling industries. My submission to you is if you were to step out, if you were to step back and come back to 2010, February 2020 now, what are the technologies outside the three that you come here to hear? What are the ones that you'd like to throw out that you think are going to make a material impact? Outside hyper-converged infrastructure, outside quantum, what else do you think is at play here? Anyone? Anyone? Someone said blockchain. Well, that's going one. What else? AI, cognitive, absolutely. What else? I'm sorry? Virtual reality, immersive technologies, the whole AR, VR spectrum that we talked about. What else, folks? I heard something from there. You're either too soft or I'm too deaf. Quantum, absolutely, and we're going to talk about it. What else? Okay. Anything else? We could talk about outside quantum, we could talk about outside hyper-converged infrastructure, and we could talk outside the post-digital cognitive world if we wanted about drones. We could have talked about autonomous things. We could have talked about, we're talking HCI, we could have talked about edge computing. The conversation over the next few minutes, the next 1 hour actually, is fundamentally going to be structured around trying to get a sense in terms of which are the technologies over the next 10 years that we need to bet on. And to that extent, and in that light, I'm very pleased to introduce our first speaker for the conversation today, Brian Solis. Brian, can we have you on stage? And while you're coming on stage, I'm going to read out a quick introduction of Brian. Brian, folks, can we hear it for Brian, please? Let me just run through this, and then I hand the stage over to you.
All right, I'm going to go get the remote.
Sure. Brian is a world-renowned digital analyst, anthropologist, and a futurist who has been called one of the greatest digital analysts of our time. Brian is also a world-class keynote speaker. You're about to hear him, and an 8 times best-selling author. Based in the Silicon Valley, Brian studies disruptive technologies and its impact on business and markets. Key areas of focus include cognitive automation, corporate innovation, digital transformation, customer experience, and evolving digital behaviors. Through his advisory practice, custom research, and published work, he humanizes disruptive trends to help leaders understand how technology, markets, and people are evolving and how to drive innovation and growth. Finally, with a loyal audience of over 700,000 people online, his work makes him a sought out and sought after thought leader to leading brands and vendors. Ladies and gentlemen, Brian Solis.
Thank you. Good morning. Who's ready for PowerPoint slides? Yes? Okay, me too. It's a real honor, a very, very much a privilege to be here with you. I traveled from San Francisco, and it's always a treat to see my friends here in Mumbai. My friends here in India have been amongst the earliest supporters of my work going back to the early 2000s. So it's very much a very special time to be here. So thank you. Quantum computing is perhaps one of the most difficult technologies as an analyst that I've had to study because it is incredibly hypothetical. And it's also something that scientists have been exploring for 120 years. And here we are talking about it as if it's going to appear tomorrow, which, for the record, it's not. But early signs of promise and possibilities are here with us today. And that's what I want to share with you, is sort of this philosophical conversation about what we need to think about, why, and what we need to do leaving NASScom. And the reason why this is important is because I think we can all agree that no enterprise moves like a startup. Things take time. And it's not just time. It's a lot of other things like education or resources or things like politics and other human obstacles that get in the way of innovation. If you think about all of the things that we have to track today in technology, both emerging, disruptive, and evolving, it's almost impossible to keep up with everything. And here we have quantum computing, the most obscure, but also probably the most disruptive of all technologies before us. And obscure in that it's nothing like we know in terms of bits, zeros and ones. You have electrons that could be in the same place at the same time. You have objects that could be both waves and particles, opening up superpositions and entanglements for all kinds of different processing powers and different possibilities and outcomes. So the question that I was presented with when we were talking about what this session would be, can quantum computing solve all of our problems one day? I'm going to take a guess and say yes. I'm an optimist. But it's not just about the problems. We're going to have a lot of problems getting there. It's also about the opportunities that it creates. There was a conversation yesterday how we could completely deconstruct and reconstruct and predict the human genome. I'm pretty sure that You talk to any climate scientist, and they're going to talk about how some of the first algorithms they're going to develop are going to be focused on global warming and reversing that. So yes, it can solve our problems one day, but to get there, since we're talking about an entirely new paradigm, an entirely new processing capability, that's going to require new algorithms. That's going to require new systems. That's going to require new thinking. In addition to being a digital analyst, I'm also a digital anthropologist. I can tell you one of the biggest challenges that we're going to have facing quantum computing is ourselves. Can we see the problem and the opportunity in such a new light that we can dedicate ourselves with a beginner's mind? Because that's what it's going to take. I mean, I don't know that we have another choice, because it's that radically different. This is a quote that's often attributed to Einstein, but it's actually not his quote. But it's perfect when it comes to quantum, is that we cannot solve today's problems or tomorrow's problem with the same thinking that created them. And so this is why quantum, I believe, is so important. It's not just a new technology, it's actually an opportunity for an entirely new genre of operations, of computing, of philosophy, of the social sciences and how it is involved within the organization. And it's just an extension of all of the things that we have to invest in today anyway. Artificial intelligence and machine learning, those are two technologies that have the opportunity to give us a more human-centered approach to business, not just augmented and automated like we're seeing it done today. So I live in Silicon Valley, and in Silicon Valley, one of the things that we're always asking is, what's the next curve? For example, what's the next curve after the smartphone? Because it's surely hit its peak. When I think about the evolution of the enterprise, we're still largely in this era of digital transformation. And digital transformation means so many different things to so many different leaders, so many different organizations. It's unique to each company, yet I think what we all share is that we'll invest in cloud, we'll invest in replatforming, we'll invest in cross-functional steering committees so that we can take the enterprise forward collectively. But now, with AI and machine learning, we're sitting, for example, at the cusp of a cognitive enterprise, which I know has been discussed here quite a bit. But a cognitive enterprise is already upon us, and that too, like quantum computing, needs to change the philosophy, operational models, processes, how we organize and operate our businesses in an era where your systems can make decisions. That too requires new algorithm development, new skills development, eventually creating what, for example, Era Technology calls a self-driving enterprise. And then following that, maybe 5, 10 years on an optimistic scale out, is this idea of a quantum enterprise. As an analyst looking at quantum, I come to it with a beginner's mind. No fluff, no predictions, other than a very humble approach that this is a really big deal. It's transformative, it's threatening, it's also promising. Where we are today is not like conversations about AI and machine learning. With quantum computing, we have time. It is so radically different that we have to consider and appreciate that time to think about how we structure ourselves internally differently. When we think about quantum, what we're really talking about is fault tolerance. We're nowhere close to that yet. There are all kinds of players available today who are sharing with us their technologies, they're sharing with us their thinking, their white papers, their experiments, their tests. But really, to get there, we need 1 million qubits. Right now, we're not necessarily even experimenting with 50. 1 million is the number that's suggested because that's where we need to be for error correction. Why that's important? Well, where we are in the whole grand evolution of quantum is what John Preskill called the noisy intermediate scale quantum. And it's described as this sort of awkward state that once we experiment with pre-quantum systems with around 50 to 100 qubits, that we will know, that we will be able to solve an algorithm that will truly test quantum's potential. We will know at that time that quantum is not only possible, but it's inevitable. It's on the horizon. And so the reason why this is an important conversation right now is because it could be any moment in the next few years that breakthrough is going to happen. And it gets its really weird name because algorithms, quantum itself, is highly sensitive to noise. Not enough qubits to be fault tolerant. It's called intermediate scale also because all of the experiments that will be done between now and the end of this era are going to be experiments that are pre-change the world levels, meaning that we're not going to solve climate change during this period, but we are going to know that we're on the right path. This sort of shows where we are today, which is on the left side of things, sort of pre this NISQ state, that this state is expected to last maybe 5 years. But once we get through this stage is when quantum really starts to show its potential and to show its promise. Once that starts, it's probably pretty late to get started as an enterprise. Already today, we're starting to see experiments show promise. For example, we have molecules being simulated. We have Volkswagen experimenting with full transportation grids that are optimizing transportation for taxis, for example, and public transportation utilities. We know it's happening, but why I wanted to share this with you is if Volkswagen is already showing that it can work with its taxi grid, that means Volkswagen's already applying significant resources to quantum experimentation. Not just from a technology standpoint, but from an expertise standpoint. Because when you program on a qubit, that is completely different than how we're thinking about classical or even supercomputing today. By the way, if this deck is interesting to you, I can send it. Just send me an email. Every slide includes source notes and links so that you can read deeper and deeper and deeper into all of the applications that are already being tested. What I'm sharing here is a list of already announced verticals with companies behind them that are investing in quantum, early quantum experiments to solve these problems. What's really interesting is that they're all using an incredibly innovative technology to essentially do things better today. I call that iteration, right? Iteration is doing the same things better. Innovation is doing new things that creates new value. So I see the opportunity for quantum in both areas. Iteration, so improving, for some of us, over 100 years of business, and also innovation to create that new value. Because what we see today is that the stack for quantum is already starting to take shape. Not mature by any means, but I share this with you as sourced by the Friends of Boston Consulting Group, is because this shows you that there's a sandbox already to start playing in. Now's the time. You have some of the biggest companies, some of the most ambitious startups in the world that are already starting to simulate these early quantum developments. And so what I want to share with you in closing, I believe that every company that wants to compete for the future not only has to get through all of these evolving technologies like AI and machine learning and you name it, AR, VR, whatever's on your horizon, right? This is why digital transformation, there is no end state. It's just now a continuous ecosystem within the enterprise. We're always going to be evolving. The difference is with quantum, especially following a cognitive and self-driving enterprise era, we have to build that infrastructure now. Who is going to lead that initiative, right? These are conversations we probably should have had a couple decades ago when we were talking about AI and machine learning. So whether it's a center of excellence, whether it's a steering committee, whether it's a pilot practice, whatever it is within the organization, it needs to exist. Because someone has to lead the opportunity analysis that exists right now. Because there are already a growing list of competitors who are investing capital and resources in not only understanding quantum, but starting to experiment with it. And that is because the more experience they gain, the more competitive advantages that they're going to have over time. You should also consider not being a fast follower, but being a leader. First to market, thought leadership, innovation, even having that ability to communicate that you're experimenting on these fronts is a competitive advantage. Innovation is proving to show time and time again to be not only a competitive advantage, but it's creating preference in the market, which generates perceived value, whether that's through shareholders, stakeholders, revenue, however you want to position it. And share those pilots. Demonstrate that first mover advantage. Be a first mover and a fast follower, because I think that's what we're starting to show as successful models within the enterprise. Digital transformation gives you that agility, or it should give you that agility, to be more, not just flexible, but adaptive, and also a leader in what's going to be inevitable. And I also believe that as you start to gain this experience and this expertise within quantum, it's also going to show you within the rest of the organization where you can reverse engineer a lot of the other emerging technologies to be effective right now. Because I can tell you that in some of the research that I did around quantum, that there's these hybrid quantum experiments with classical/supercomputing experiments where they're simulating things right now that weren't possible before because of the new thinking. And so coming back to the original question, can quantum help us solve our problems? What I want to leave you with is something that we don't really get a chance to talk about too often in IT or technology or in enterprise evolution, which is creativity and imagination and all of the other humanities. Steve Jobs once said that Apple sat at the intersection of technology and liberal arts. When I think about quantum computing, this is a completely revolutionary paradigm. And I think it will be at its greatest, not just when it's available, but now. That new thinking, that beginner's mindset, that wonder, those possibilities, that curiosity, that drive and ambition that allow you to see things differently, to experiment with hybrid models today, to experiment with early quantum models today, to not just solve problems, but create new opportunities that help your enterprise, but that also change the world for the better. This is your time. Thank you very much.
There's a question right here in the front row. Can we get a mic out here, please?
This is a beginner's question, not a beginner's mindset question. So quantum at its core, what is the physics? And what does it give to us which today's computers don't give in the electronics, which is miniaturization, higher speeds, more memory. So in quantum, what is that aspect, what is the crux or core of the quantum physics, which is giving us a new capability, and how would you describe it for a beginner?
All right, so this is a question that I feared, because the physics of it is what is so confounding. I'll give you an example. At the beginning, when I talked about electrons occupying two states and then also having waves and particles coexisting, when we think about classical computing in zeros and ones, that's what we're designing algorithms for. The circuit boards are constantly optimizing and scaling that. You have Moore's law, you have all different laws that sort of govern how far that can go. With quantum, because you have so many simultaneous states, the entire circuitry, the physics of how those things collide, how they spin. For example, somebody told me that you could have a really good example is if you thought about a coin with the 0 and 1 coexisting, and you spun it, and then you asked it a question, you asked it to solve for that problem. That's the system that we're designing for. So the physics of it, this is what I think makes the algorithmic, the software development, and the circuit board development of it so complicated, because you're designing for essentially a paradigm, a model that our brains aren't even linearly capable of imagining yet, right? So when we see some of these early qubit algorithm designs, and some of the tests, for example, say if we could get a quantum computer to solve this particular problem, we will know we're on the right track, is because of the difficulty of the question that you just asked. This is, in all possible meanings, a new generation of design. And for anyone who designs on classical, whether that's in hardware or software, the thing that I ran into time and time again in my research was the need for people to start retraining now around answering your question. So it's the best I have for you.
Any other questions, folks? There's a question right there.
Hi. So quantum computing is, as you said, the companies need to jump on this and grab the opportunities. But at the core, it still seems to be an academic problem first to be solved. So how do you see enterprises and the academia partnering up for the next few years? Because that is what will make it ready for the enterprises to adopt something.
That's a great question. It's one of the things that I specifically set out to answer. In one of the slides that showed all of the existing applications, there's a link at the bottom of that, so if you send me an email, I'll send you the deck. It talks about, there's a section that talks about how you can get involved today. What I felt was so interesting about that section was that it was incredibly ambiguous. It was, go get involved. When I look at the technology stack in the slide that I shared earlier, every one of those companies, small and large, so Google, IBM, you have some of the early players, they're all creating groups for enterprises to participate in now. They have sandboxes available so that enterprises can essentially start to plug in, start to learn, start to experiment. You don't even have to talk to another human being. You can actually just start going through the libraries. You can start plugging into the sandboxes that they have available. That is exactly where I would start, is starting to understand what this looks like so that we can assess resources. I think the early thing about establishing a COE, many COEs are often small at the beginning. That is going to determine what your roadmap is going to look like. And eventually, as you start to, for example, IBM has been very, very vocal with their sandbox availability to enterprises right now for a long time. It's at least going to answer this question for you of what is it going to take? And more importantly, at what point do you activate a relationship with a partner to start formalizing that experimentation? And by formalizing, I also mean having expert validation, expertise, training, et cetera, immersion. That's where I would start.
Great. Thanks a ton, Brian. Fascinating conversation as always. I know we're running against time. We have
Just
two other
one last
speakers.
question, please. Brian, you had said that there are two things which you had.
Where's the question coming from? Oh, out there. Okay.
Brian, you just said two things, and I wanted to, you to articulate this a little bit further. You'd said that we would know if quantum computing is working based on the kind of problems that we set out and the answers that come as a result of that. But isn't there a catch-22 in this? I mean, we set up a problem. We anyway don't know the answer to that, okay? And we say that we know it works based on the solution that's thrown up, point one. The second thing you're talking about is the coin, okay, the heads and tails fused, and you spin it, and you then say, what's going to be the result, all right? Isn't this a sort of Schrodinger's cat kind of a situation, It's extremely theoretical, and it's great, abstract, when we're talking about physics, but when we talk of computing and when enterprises have to invest, okay, we need to go from the abstract and the abstruse, isn't it, to what is possible and what kind of ROI we are once going to see on it, and how do we transcend this little shift here? So it's really two questions, and I would love it if you could articulate further.
I'll give it my best. The cat example is exactly right, because it's both alive and dead at the same time. That, I think, is what makes this so abstract and theoretical, is that exact thing, because that's what you're designing for. The thing that I find most promising, at least in the stack as it exists today, is that there are two or three algorithms that have been developed as sort of this test that's going to allow us to know when we enter this next phase. And the solution to that algorithm is not game-changing, it's not world-changing, it's simply a demonstration that we could solve that particular problem. So that, I think, is where we get beyond the theoretical and sort of this official green light. I think we're before that green light that tells us, yes, we're on the right path, and now things start to get really serious. In terms of the second part, right, in getting things much more tangible and demonstrating that ROI and moving forward, this is why I think towards the last question about participating in some of the open groups that exist today and starting to experiment with some of those sandboxes, we can ask questions that allow us to at least get into the mindset of what we need to think about. If we had to prioritize what our investments were going to be, if we had to think about what are the top problems we need to solve, or where there are areas of opportunity to demonstrate the most immediate ROI, some of the things that I found weren't necessarily with quantum directly because of the early stage we're at, but was in this hybrid methodology between classical and then also quantum algorithm development. So essentially, you're using classical / supercomputing infrastructures today to simulate low qubit designs in quantum, but to give you, number one, expertise, but also results between a hybrid system that actually starts to demonstrate ROI today. And in the deck, I included a link for that so that we can start thinking about how we're addressing high-impact, early ROI opportunities so that, like anything within the enterprise that's new, we don't want it to just be a cost center, and we don't want it to take away precious resources from everything else that we need to invest in.
Great. Ladies, gentlemen, Brian has another session that he's going to chair at 10:30, so he's going to be one out of the three speakers who's going to step off the stage. As he moves on, can we just hear it once again for Brian Solis and for his talk, please?
Thank you.
Great job.